In today's video, we're going to be taking a look at binomial expansions for A-level maths. By the end of the video, you're going to know how to expand problems in the form of 1 plus x to the power of a non-positive integer and problems in the form of a minus x to the power of a non-positive integer. Now, before we go ahead and get started, it's important to understand why we actually do binomial expansions and why do we need to know any of this. The reason why is because it enables us to solve complex problems like these. Now, it's important also to understand in what situations do we actually use this formula. Well, the answer is when the n value, so the power value, is a non-positive integer. So it could be 3 over 2, it could be 1 over 2, it could be 4 over 3, it could be negative 2, negative 6, negative a half, etc. So when the n value is not a positive integer. Let's quickly take a look at the expansion itself. So we have 1 plus n times x plus n times n minus 1 over 2 factorial times x squared. Now, what does factorial mean? What does this sign mean? It simply means that we have to multiply all of the integers, so the integer we have, and all of the integers that are less than it. So this here, 2 factorial, will be equal to 2 times 1. The next term will be n times n minus 1 times n minus 2 over 3 factorial times x cubed. 3 factorial is going to be 3 times 2 times 1, and this will continue. Let's quickly take a look at the validity of a binomial expansion. So it's valid for when the modulus of x is less than the a value, which in this situation here is 1. So for the modulus of x is less than 1. And at the end of the video, we'll actually take a look at what happens if it is not less than 1, if the modulus of x is not less than the a value. So let's actually go ahead and solve some problems. The paper is asking us to find the first 3 terms of these two binomial expansions. So we have our 1 plus x, which is the same as this formula here, and we have our n value. So let's go ahead and substitute these values into this formula and see what we get. So we have our 1, so it's simply just going to be 1. Then we have plus n times x, so our n value is negative 2, and we're multiplying it by x, so it's simply going to be minus 2x. And then we have this value here, so it's going to be n, so negative 2, so it's plus negative 2 times negative 2 minus 1 over 2 factorial times x squared. Okay? Then we simplify this, so 1 minus 2x, and then this here is going to be, so negative 2 times negative 3 over 2 factorial times x squared. So now we're going to have 1 minus 2x. This here is simply going to be negative 6. Sorry, it's going to be negative 2 times, it's going to be positive 6, so we're going to have negative 2 times negative 3 over 2 factorial. That's simply going to be 3 multiplied by x squared. So it's going to be 3x squared. So that is those are going to be the first 3 terms of this binomial expansion. Now here, where we have 4 minus x to the power of negative 1/2. It's slightly different. So we need in order to use this formula, we need it in the form of 1 plus x to the power of n. So what we can go ahead and do, well, what we actually have to do, is we have to bring out the 4. And so what that's going to do is it's going to be 4 multiplied by 1 minus x over 4, close the bracket, to the power of negative 1/2. Okay? If we were to multiply, so if we were to redo it to check if we get the same answer, it's going to be 4 times 1, so we get the 4. 4 times negative x over 4, the 4's will cancel out, and we'll be left with negative x. So we're certain now that this is the first step is correct. The second step is then to say, okay, if we have this, what it's going to be equal to is 4 to the power of negative 1/2. So 4 to the power of negative 1/2 multiplied by 1 minus x over 4 to the power of negative 1/2. So what we can see here, 4 to the power of negative 1/2, so 4 to the power of negative 1/2 is simply 1/2. It's simply going to be, so 1 over the square root of 4, and then we're going to be multiplying by the binomial expansion of this bracket here. So we have 1 minus x over 4 to the power of negative 1/2. So if we look here, we're going to have that 1 value, so it's going to be 1. Then we're going to have n times x, so negative x over 4 times negative 1/2. That's simply just going to be 1 over 8, so x over 8. So it's going to be plus x over 8. Then we're going to have this part here. So it's going to be plus n, so negative 1/2, times negative 1/2 minus 1 over 2 factorial multiplied by x squared. Now what our x value here is negative 1/4. So it's going to be negative 1/4 x squared. Okay, always make sure that you remember that. And then we're going to go ahead and simplify this. So 1 over the square root of 4 is just going to be 1/2. So we're going to have 1/2 multiplied by 1 plus x over 8. Now here we have negative 1/2 times negative 1/2 minus 1. So if we do this, so negative 1/2 multiplied by negative 1/2 minus 1, that's simply going to be 3/4. And then we have this 2 factorial. So divided by 2 factorial, and we're going to get 3 over 8. So we're going to have plus 3 over 8. And remember, we have that there. So negative 1/4 squared is going to be 1 over 16. So it's going to be 1 over 16 x squared. Okay, and then that's going to simplify down to 1/2, 1 plus x over 8, plus 3/8 times 1 over 16 is going to be 3 over 128. So 3x squared over 128. And then we have to multiply the 1/2 by each of those terms. So it's simply just going to be then 1/2 plus x over 16 plus 3x squared over 256. So that is going to be the binomial expansion of this question here. Now, as we move on, I want to quickly take a look at the validity of these binomial expansions. We've solved them, but we haven't actually stated the validity. So the first thing I want to do is look here for this validity, because this is one of the most complex questions. So before we said that the modulus of x has to be less than the a value. So let's go ahead and say, if we have the modulus of 3x squared is less than 1, we're going to divide both sides by 3. So we're going to get x squared is less than 1 over 3. And then take the square root of both sides. So the modulus of x is going to be less than the square root of 1 over 3. So that's going to be the validity for this question. For this question here, we have x, and this is our a value. So it's going to simply be the modulus of x is less than 4, right? Our a value. For this question here, we have our a value is 1. So the limit, the validity of this binomial expansion is going to be when the modulus of x is less than 1. Okay? So those are the validities of these different binomial expansions. Now, what happens if we do not have what happens if the modulus of x, let's say, or x is equal to 2? What's going to happen then? Well, in that situation, what is going to happen? So, if we put in our calculator 1 plus 2 to the power of negative 2, what we get is 1/9. Okay, so we get 1/9. Now, if we then go ahead and substitute in 2 into this equation here, what we're going to get is 1 minus 2 times 2 plus 3 times 2 squared. That's going to be 9. So this value here is going to give us 9, and this problem is going to give us 1/9. So they're completely different. Whereas if we were to choose if x was 0.5, let's say, right, so within the limit that we've set, what we're going to get is we're going to have 0.75 as that's going to be our binomial expansion value. And then here from the initial problem to the power of -2, we're going to get 0.44. Okay, so they're much closer. And as we do more expansions, right, so as we get x cubed, as we get further expansions, we're going to get a value, this value here, this expanded value, is going to converge towards 0.44. So that is why we have to have these limits, because without them, we're simply going to get a expansion that is going to diverge from the true answer, whereas we want the binomial expansion to converge, right, to come towards the value, the true value of our problem. So that's it for this video. If you found it helpful, take a look at some of the other content on my channel that might interest you. Otherwise, thanks very much for watching, and I hope you have a great day. Bye-bye.